What is that?
Him.
Who are you?
I am Dmitri Mendeleev, and this is my periodic table. Well, technically, John Newlands published it in 1865, but mine is better anyways.
Okay.
It looks a little strange, doesn't it? Well, it's supposed to look strange.
But I don't get it.
Well, I'll explain it then. The columns are groups or families. They're called families because of all the elements. The elements in each column have similar characteristics. Look at the first two groups, for example.
But how are a bunch of random elements related?
Well, if you'd let me talk, I'd explain. Thank you. The first two groups are all very reactive. They're also all metals. All of the first and second families like to make cations by losing one or two electrons.
What are cations?
Oh, cations are positively charged atoms. Thought I mentioned that.
Okay, so columns are families. What about the rows?
The rows are called periods.
So is there a special reason why they're called periods? Like the families?
No, I'm just old. Do you expect me to accurately name every little thing? So rude. Well, since you're quiet, I'll explain the last thing. The table is also made into 4 blocks. They're called the S, P, D, and F blocks.
Oh, I know this! It's like orbitals, right?
Yes, actually. It separates the elements based on their electrons. Glad you know something. Now, the periodic table can be broken into 3 sections: metals, metalloids, and nonmetals.
But how can you tell just by looking at it?
Well, you can't, but if you would just shut up and listen. Children make me tired. It's really easy. Metalloids are to the right of the stair step, as well as germanium and antimony, which are to the left of the stair step.
So I just need to memorize where the stair step is for the metalloids?
Precisely. And for non-metals, it is everything else to the right of the stair step and hydrogen.
Oh, that makes sense. They're mostly all grouped together.
Exactly. And last but not least, metals. They're located everywhere else, or in other words, to the left of the stair step.
Oh, that's easy to remember.
Of course it is. I am never wrong. Now, within the metals and the non-metals, there are certain groups that you should remember.
What are they?
Well, if you would quit interrupting me, I could tell you.
Sorry.
The groups are alkali metals, alkaline earth metals, transition metals, halogens, and noble gases.
So where are they?
The alkali metals are softer than other metals, can explode if exposed to water, and are very reactive because they only have one valence electron, which means they are located in the first column or group, excluding hydrogen, of course.
Okay, what about the alkaline earth metals?
The alkaline earth metals are located in group 2, with 2 valence electrons, which means they're still quite reactive.
Alright, are you gonna tell me about the transition metals, or am I gonna have to
You
look this up?
children are so impatient. If you would just hush for 1 second, I could tell you about them.
Alright, I'll be quiet.
Thank you. Now the transition metals are found in groups 3 through 12. They exhibit many different oxidation states because their valence electrons are present in more than one shell. They are very ductile, malleable, and conduct electricity and heat. And iron, nickel, and cobalt produce electromagnetic fields.
Okay, sounds simple enough. Aren't there still two more?
Yes, there are. Halogens and noble gases. Halogens are in group 17, and noble gases are in groups 18. Halogens have 7 valence electrons, and noble gases have 8, except for hydrogen, which only has 2. And altogether, halogens exist in all 3 states of matter, which are...
Ooh, I know this. Solid, liquid, and gas.
Correct. I'm surprised you knew that. And lastly, noble gases cannot form compounds readily. So, in order to know the periodic table, you should know everything I just told you.
That's a lot, but I'll try.
You will try!